All right, I think I kind of left the easiest one for last, even though it might not look like it because there's a fraction. It'll be the easiest one, I think, to write what f of x plus h is and actually do the math from there. So let's go ahead and figure out off to the side here, what is f of x plus h? Okay, so we plug in x plus h for x in the original expression. And I would go ahead and simplify that a little bit, right? So we'd have negative 1/2 x minus 1/2 h plus 1. Now that's our f of x plus h. So this is going to go right here. And then we have this is going to go right here. So let's go ahead and write out our limit with all of that information. So we have the limit as h approaches 0 of f of x plus h, which I have written in the pink there. So negative 1/2 x minus 1/2 h plus 1. And then we have minus f of x, which is just negative 1/2 x plus 1. And that's all over h. So no exponents here, nothing real difficult, just a little bit of algebra. So let's simplify that numerator and hope that we get rid of everything that doesn't have an h in it. So I'll have negative 1/2 x minus 1/2 h plus 1. And then the reason I always write that f of x in parentheses is because you have to make sure you subtract everything. So minus negative 1/2 x is going to actually be plus 1/2 x minus 1 all over h. And then we look for things that are going to become 0 when you add them, negative 1/2 x and 1/2 x, 1 and negative 1. And what's beautiful about that is all that's left is something that has h in it. And then we look for that giant 1 with the h and simplify our expression a little bit. So we have the limit as h approaches 0 of negative 1/2. And this is really similar to one you did earlier in this problem or in this practice. The limit is going to just be negative 1/2 because that's a constant function. So no matter where you're approaching it, it's going to have the same output.